Hello guys, welcome to a new video, and in this new video we are going to talk about EIGRP, but I'm actually going to do more of a presentation of EIGRP, which is a Cisco dynamic routing protocol. Okay, and what is EIGRP? You guys should know it by now, but if you don't know it, it is an advanced distance vector routing protocol. And this protocol is an evolution of an earlier Cisco protocol called IGRP, okay, which is now considered obsolete. So we don't use IGRP at all. And IGRP supports classless routing and VLSM, routing summarization, incremental updates, load balancing, unequal and equal load balancing, something that OSPF does not do, and many other useful features. Okay, so EIGRP routers use a multicast address of 224.0.0.10. Okay, and here are some show commands that you can do. When you do this show IP EIGRP topology, it shows you the topology and how EIGRP it's working. When you do this show EIGRP traffic, it shows you the stats of the traffic coming in and out using EIGRP, and show IP protocol shows you, of course, the protocols that are running in that router. Okay, so there are some rules that you need to follow. The rules that you need to follow if you want to form a relationship with a router using EIGRP. So the first one is the key values should match. We're going to talk about key values in another slide. The autonomous system number should also match. Okay, not like OSPF. OSPF, it doesn't matter, but for EIGRP, it does need to match. Also, the authentication should match if applied. Because EIGRP supports MD5 authentication only, and also the subnet mask should be the same. If they're not on the same subnet mask, it won't form a relationship with another router. Okay, and hello and dead timers are not a factor like in OSPF. Okay, so hello and dead timers are not a factor on the neighbor relationship in EIGRP. And the router ID, so EIGRP automatically selects an IP address to use as the router ID when an EIGRP process is started, okay? But the way it does it is by using the highest local IP address. It's selected, and loopback interfaces are preferred. So if you have a loopback, it's going to start there, and it's going to take the highest loopback. If you don't have a loopback address, then it's going to take an IP address from a interface. Here we go. So EIGRP uses a combination of 4 different features to determine its metric, and these features are the bandwidth. Okay. So yes, EIGRP uses bandwidth in its metric calculation, but it uses it in a different manner as the other routing protocols, and it also uses delay. Okay, so I have a topology over here, or a network that we are going to configure EIGRP, so you guys can see how it forms a relationship with the routers. So let's go ahead and configure this. I have already configured the IP addresses and also the loopback address for every single router, and I'm going to add this network. I'm going to add this activity on the link on the description below, so you guys can download it and follow me on this activity. So let's go ahead to router 1. Let's go ahead and configure EIGRP. Enable config T. Let's change this host name to router 1. Okay, and from here, from the configuration mode, you have to put router EIGRP in the autonomous system that we're going to use is going to be 10. Okay, so network. Now we need to add my networks. The first one that I'm going to add is this one over here, 192.168.1.1, and the next one is going to be .2.1, which is this interface over here. And I'm also going to add my loopback address. There it is. And I can also, if I want to do a router ID, let's see, I think it's EIGRP router ID, and you can specify your router ID, right? But since I have the loopback configuring this router, it was going to use that loopback address anyways. Okay, so now let's go ahead and form a relationship. So the way to do that, we have to configure this router over here, enable config t router EIGRP, and let's put it as EIGRP 9. Okay, and router EIGRP 9, let's do a network 192.168.2.2. And as you can see, it did not form a network relationship, and that's because this autonomous system over here is 10 and this one is 9. And like I said before on the slide, to form a relationship, you need to have the autonomous system needs to match. Since they're not matching, they are not forming any relationship. So what I need to do, go ahead and do exit, and let's delete this router ID, and let's actually do 10, and then let's add the network, and you are going to see that it's going to form a relationship. And there it is. I have a neighbor relationship formed with router 1. Okay, and let's also add 3.1, and it's not going to form a relationship yet because router 4 is not configured with EIGRP autonomous system 10. Okay, and I'm not going to specify a router ID, and you're going to see that it's going to automatically select the loopback address 2.2.2.2. Let's also add this loopback address, and let's end it. And if we do a show IP protocols from here, we are going to see a lot of information on the protocol that is running. So we are running EIGRP 10, as you can see over here, and the way that it is using the metric, it is using the first K, right? And the first K is the bandwidth. The second one is delay, which is not using. The third one, the second one is load, which is not using. The third one is delay, and number 4, I believe, is reliability, which is not using, set to 0. And this one over here, number 5, is the MTU, which is not using. So it's only using, as default, it's using bandwidth and delay to choose a path. So that's how it's choosing a path, by doing the Ks. And I have a slide over here about it. As you can see right here, K1 is the bandwidth, K2 is load, K3 is delay, K4 is reliability, and K5 is MTU. And it's only using K3 and K1. As you can see right here, K1 and K3 for the metric weight, which is the way that it chooses its path, its best, or the best route to a network. Okay, and as you can see over here, but we did not configure the router ID, so it just picked the loopback address 2.2.2.2 because it's the highest one, or it's actually the only one in there. The hop count is 100. Maximum path that is going to have to one network is going to have 4, and the variance metric is set to 1. And you can see the routing networks that we added are these 3 over here. Okay, and we can see right here that we have some routing information to this network, which is this one over here, and it has a distance of 90. Okay, and we also can do a show IP EIGRP neighbors, and we can see my neighbor, and my neighbor right now is on gigabit 00, and this is the IP address for that neighbor, which is this router over here. But if we configure router 4, we're going to have another neighbor. So let's go ahead and configure router 4. Config T router EIGRP. Remember, it needs to match. So 10 network 192.168.3.2. Here we go. We form a relationship. So if we go over here, and if we do a show IP EIGRP neighbors, we're going to have, before we only have 1, which was this router 1, but now we should have 2. Here it is. Now we have 2 on this IP address, and this one. This one is for router 4, which is on gigabit 01, and this one is on gigabit 00, right? And this is the IP address for this other neighbor over here. Okay, so now if let's go ahead and router 4, go ahead and also add the network of the loopback address, and also add the other network on gigabit 00 192.168.4.2. And now if we go to router 1, we should have a show IP route. Let's make this bigger. So you can see right here we have a D stands for EIGRP. So we have an EIGRP route to 192.168.4.0 via 192.168.2. So we are router 2. We are able to reach router 4, and we have the other one 3, and it's also via 192.168.2.2, which is via router 2. We are able to reach this interface over here, or this network, and 4 is this one over here. So I got confused. So 3 is this network over here, and 4 is this network over here. So we are able to reach these 2 networks, and we are also able to reach this one, which is local. As you can see, C is directed, not local. Local is L. C is directly connected. We are also able to reach this loopback address, which is on router 4 via router 2 192.168.2.2. Okay, and then you can see the other loopback address, which is in router 2, and we are able to reach that via router 2, so this way. Okay, so this is great, working perfectly just the way I wanted it. Now let's go ahead and configure router 3. Enable config T router EIGRP 10. And from here, let's add, first we are going to add these loopback address 3.3.3. Then let's add network 192.168.1.2, which is this interface over here. And as soon as we do that, we are going to have a neighbor relationship with router 1. Forgot the T right here. There we go. And as you can see, we form a neighbor relationship with router 1. And if we go over here, you can see it as well. And if we do a show IP EIGRP neighbors, we can see that we have a neighbor relationship with router 2 and also with router 3 this way. Alright, so now let's add the other one, which is for that one. And as soon as we do that, we're going to form a relationship with router 4. And there it is. We form a relationship. And if we do exit again, show IP EIGRP neighbors. So you can see right here we have two neighbors, which is router 1 and router 4. Alright, so this is working great, just the way I wanted it. And remember when I said that, let's go back, that the K values should match, and a way to configure that. So if we go to, let's go ahead to router 1 and let's configure the K values, and you're going to see how this neighbor relationship is going to drop. So if we do router EIGRP 10, I believe it's metric weights, and the first one for bandwidth, we're going to leave it as for 1. And then if we configure the load to be 1 as well, and then delay 1 as well, and then reliability 0, and the last one is MTU 0. And this one 0 as well. So you can see that we are having an error over here, since the K values are not matching. Now we get a K value mismatch. And if we go to, let's go to router 3, now we should only have one neighbor over here, which is router 4, because like you said over here, to form a neighbor relationship, the K values should match, and since they're not matching right now, we do not have a neighbor relationship. So what we can do to fix that is we can just edit this to be 1 0 1 0 0. Let's see. If it lets me do it. There we go. So we are able to set it as a default, and it's still saying mismatch. So 0 1 0 0 0. What we can do is just do a no. It's not gonna let me. Mismatch. What we could do is, let's go ahead and put it right here, and let's do metric weights on 1 0 1 0 0. Let's go ahead and copy that, and let's put no to negate that. Oh, I believe I put it as 1 1 0 0 0. So let's go ahead and edit that. There we go. And as soon as we say no to the metric weights, now we can see that we have a neighbor relationship with router 2 and also with router 3. And we can see, we can go back here and do show neighbors, and we can see that we have our neighbor back, which is router 1. Okay, because remember, the K values needs to match, the autonomous system needs to match, and they need to be on the same subnet mask, and also the authentication should be the same as well. Okay, now, so we're about to talk about the key values and how they're useful, and how EIGRP calculates its metric by using the bandwidth, delay, reliability, MTU, and also load. But when you misconfigure them and they're not the same for every single router, what happens is that the neighbor relationship drops, as you saw when I edit these metric values. Okay, so now let's go ahead to the next slide. And this is how EIGRP picks its successor and feasible successor. So it uses this diffusing update algorithm, which is dual, which is an algorithm used by EIGRP to select and maintain the best route to each route network. Okay, so this is the way that it picks the best route. So whenever it has the best route, what it does is that it picks the successor for that route, and if that route goes down, then the feasible successor, which is the backup route to that network, it becomes a successor. Okay, so I'm going to show you how that works, and let's go over here and end it to a show IP route EIGRP, just for EIGRP. And you can see right here that let's pick this one over here. You can see that this to reach this network over here, well, let's actually pick this one, which is this network over here. So to be able to reach this network, we need to go via 192.168.2.2, which is on gigabit interface 00. But what happens if that interface goes down? All right, let's go ahead and shut down that interface. Let's go in, show IP route EIGRP. As you can see now, to reach this network, now we have to go the other way. Now what happens is we need to go this way to reach this destination, because this IP address or this interface is down. But now, since we have another route, which is this way, what it's going to do is that since this one is no longer working and it was faster to get to that interface or to that network over here, now we need to go this way, which is another route. It's a longer route, but it is the one that is working. But if this interface comes back up, what it's going to do is going to delete this route. It's going to delete this route, and then it's going to add this gigabit 00 again. So we can see that by going to config T again, go to that interface, do no shutdown, right? So let's go ahead and end it, and let's go ahead and show it again. And as you can see now, that this interface, to access this network, we go via 192.168.2.2, which is this way because it's closer than going 1, 2, right? We can just go 1 and 2 and it's right there, instead of going 1, 2, and 3. And I can show you that by doing a trace route 192.168.3.1, which is this interface. You can see right here that it is actually going this way to get to this route. But if we do a config T again, and let's just shut down this interface, let's go in and let's do a trace route again. Now, as you can see, it's doing 3 hops instead of 1 because this interface is down, but we still have another route to get to that network, which is this way. And that's how this successor and feasible successor works. The successor is actually the closest one to the path, and then the feasible one is the backup. And what happened is that since this successor is down, the feasible successor becomes a successor, and then we are still able to reach this network. Okay, and also we have hello and hold, and the hello timer, the interval in which EIGRP sends hello messages on an interface, and is every 5 seconds by default. The dead timer is the interval in which the neighbor will declare dead if it's not able to send hello packets, and it is 15 seconds by default on EIGRP. But we're not really going to configure this because hello interval and hold timer does not really matter for the routers to form a neighbor relationship, right? If we go back, then I said it over here that hello and dead timers are not a factor like in OSPF, right? So to form a relationship with routers on the same EIGRP autonomous system, the dead and hello timers are not a factor, but they are a factor in OSPF. Okay, guys, so this is it for this long video tutorial on how EIGRP works and how they form a relationship, how the feasible successor and the successor works, and we also configure router IDs. We saw how it forms neighbor relationship, and you guys were able to see how you can configure EIGRP and how everything works. So I hope you guys enjoyed this video, and if you guys enjoyed this video, just go ahead and subscribe to my channel because I have a lot more video like this coming. The next one I believe I'm going to do is I might do 2 more EIGRP tutorials and a couple more troubleshooting EIGRP networks. So if you guys enjoy my video, just go ahead and subscribe to my channel, and also follow me on Twitter at CCNA Daily Tips. So thank you guys for watching, and I'll see you on the next one. Bye bye.